All right, so for part A, we have a function inside of which we have a for loop. So hopefully you've had time to analyze what the runtime of this function is before watching this. But basically, we need to consider two cases. What is the worst possible runtime? Well, remember that do something is going to take constant time because any other function call is taking constant time. And the for loop is actually going to iterate from n to n squared, and we're updating the variable by 1 every time. And so basically the number of iterations that we're doing is n squared minus n, approximately equal to n squared minus n, right? Okay, well, is there any way that we can bypass this number of iterations? Can we do it in shorter number of iterations? The answer is no, because no matter what n is, right, we are always going to iterate through the for loop n squared minus n times. And the work that we're doing inside each iteration is a constant amount of work, and it's always a constant amount of work. We can't break out of the for loop before we reach the termination condition. So actually the worst case and the best case in this problem are going to be the same. And so they're both going to be, and remember that we can simplify this to n squared, and so the worst case is going to be theta n squared, and best case is also going to be theta n squared.